All right, guys, we're going to do a little review of piecewise functions. So we're going to start with increasing, decreasing, and then we'll look at evaluating. So for increasing, decreasing, we are quite literally looking to see if the line or the function goes up from left to right, up from left to right. So it's going to be a positive slope. For a linear, it's usually in y equals mx plus b form. So we're looking for the number before the x. So is it positive? Yes. Then it's increasing. Is it negative? Well, then it's decreasing. That's a negative slope. And you'll see it in quadratics as well, and I'm going to show you that just a little bit down here. But we are looking for, does the function increase? Does it go up from left to right? For decreasing, it is the exact opposite. Does the function go down from left to right? So as x gets bigger, does y get smaller? Or as x gets bigger, does y get bigger, right? And it could look like this if it's a quadratic. It could look like this. It could look like that would be a decreasing if it was, then that would be the increasing part right here. If it was an absolute, that would be the decreasing part there. So if you see an x squared function, right, that's going to be a quadratic. We're going to have that x squared plus 2x plus 1, right? So we look at it and say, okay, well, we know that's going to look like a U shape, right? So let's think about this. This function is increasing and decreasing and has one point, that vertex, which is not increasing or decreasing, right? So if it's a positive a, then before the vertex is decreasing and after it's increasing. If it's a negative a, then it's frowny, right? And we remember this in that silly way, like positive parabola smile, a negative parabola frown. And I know it's silly, but it does really kind of help you remember just off the top of your head. So this would be a positive a. So everything before the vertex, everything less than the vertex. So when x equals everything less than your h for your vertex, it is decreasing. When x is greater than your h for your vertex, your x value for your vertex, it's increasing. And this would be the opposite. So less than would be increasing, less than your, remember your vertex is your hk value, we know that. So that's why I'm saying h. But the x value for your vertex, anything less than it is increasing, anything greater than it, going to the right, is decreasing. Okay? Absolute value, same concept, right? So if it's going down, then it's decreasing here. It's not decreasing or increasing, and it's increasing here. So it's the same thing. It will increase and decrease, and the vertex, that point in the middle, is neither. So this side's increasing and this side's decreasing. If we look at it on a graph, it makes sense to us, right? It's when we just have the function. So just think of it, it's the same as a normal function. You just have to evaluate multiple functions together. That's why we call it piecewise, because it's pieces of functions on a graph. And then we talk about domain being an x value and range being a y value. So let's look at an actual function. Okay? So this is on your Piecewise Functions paper. It's on the back, number 7. So I say, I'm going to draw a line between them, and then that delineates what we're looking at, okay? And so when x is less than or equal to 2, I want to look at this function. Okay, well this is a linear function, right? So it doesn't have an x squared, it doesn't have an absolute value. So I'm just looking at this number before the x. Is it positive or negative? Well, this one's negative, so it's decreasing. So I come over here and I write a little d for decreasing. And then I look here and I say, okay, cool, no x squareds, no absolute values, nothing I need to worry about. I'm just going to look at my slope. Well, this is positive, so that would be increasing. So now when you say, is this increasing or decreasing, or when is it increasing and when is it decreasing? Well, it's decreasing in this scenario. So it's decreasing when x is less than or equal to 2. And when is it increasing? It's increasing in this scenario, when x is greater than 2. Now let's look at our domain. Our domain is our x value. Is there anything in here that can't belong? So anything less than or equal to 2, and then anything greater than 2. Well, nothing's being excluded. It's all x's, right? So that's when we write x as x is a real number. Right, this one. Or we could write in our interval notation, negative infinity to infinity, and you've heard me talk about how ugly my infinity signs are, so I'm sorry. That's what those are supposed to be. Right? So basically, x can be anything. Now our range, we can look at and see, is there anything that can't happen here? So what we're looking for in our ranges, is there an x squared or a absolute value or anything like that that says, whoa, we can't have a number. No. So in this case, our y is the same. So you could say negative infinity to infinity. Oh, hi there. I did warn you. I did warn you. Or you could say y is a real number. So there are times when the range, when you'll have, like here, x squared. So this is going to be a parabola, right? So there's going to be a minimum point on that vertex where that's not going to exist for y's. We don't look a lot at domain and ranges, right? We just kind of want you to understand what they are and how they work with piecewise functions. So this paper has all domain and range, but we only did the first two with domain and range. I created it before I edited out the domain and range. So I'd already pushed it out that way and I'd already printed it out that way. So I left it in there as practice, but the domain and range is not required on these. We just walked through the first couple to see on the first page. We just kind of went through and we said, okay, this can be anything, but this one here, this stops at 5, right? So domain and range, just kind of an idea to look back because it's always good to understand how they work, even with piecewise, but what we focused on here was increasing or decreasing. So let's go to this next one. And we have, like I say, I put a line down. If there's 3, I put lines between all of them, okay? I think it's a lot easier, and it's easier for me to show people. That's personal choice on you guys, how you want to do it. So when x is less than 1, I'm going to look at my function and say, okay, no x squared, no absolute value, so I'm looking at my slope. So that is increasing. And here, same thing. I'm looking at my slope, and that is decreasing. So we have, it is increasing in this scenario when x is less than 1, and it is decreasing in this scenario when x is greater than or equal to 1. All right, let's look at this one down here, because this one has fun stuff, right? So this is a normal function, and it's a positive slope, so it's increasing. This one, it has multiple values for x's, but all the values for y are the same. So if all the values for y are the same, this is a horizontal line, right? So this is not increasing or decreasing. So I will usually draw a straight line to remind me that I checked that one, so later I don't have to go back and check it again. Is it increasing or decreasing? But it's not doing either. So sometimes that'll be a single point, and I'll draw an actual dot, and sometimes it'll be a straight line. Now we get down here and we say, okay, well, x squared, that could be increasing for negatives. You know, it could be like this. So it could be decreasing and then increasing. So then we have to look at our x values and say, okay, do I have negatives and positives here? Well, I don't in this scenario. In this scenario, we only use this function when x is greater than or equal to 10. So they're all positive numbers. So they would be increasing. So this piecewise function would have a linear function, and this is not true, right, because it's not 3x plus 2. This is a lot different. But it would have a linear function, and then it would have a straight line from negative 6 to 10, and then after 10 it would have this part of the parabola, right? And that is horribly drawn. But just to see, so it'd be a line, it'd be a horizontal line, and then it'd be the right half of a positive parabola. So that's what this would look like on a graph. Ugh, right? But what we're looking at is it increasing, is it decreasing? So these, you're just looking at slope, and when you have squares or absolute values, you're looking at what's my set of numbers, and is that affected? If it was affected, then we'd have a cutoff. We'd be like, okay, when x is less than 0, it's decreasing. When it's greater than 0, it's increasing, things like that. But here, they're all positive, it's great, it's increasing. So we're going to say this is increasing when x is less than -6, and when x is greater than or equal to 10. And then what I had people do is tell me when it's not doing either one. So sometimes you'll say this as neither, and sometimes you'll see it as stagnant when it's not doing either. And that would be from -6 less than or equal to x less than 10. So this is the neither. And we kind of wrote these in on a couple of them just to see what that looked like. I wasn't requiring in all of them, but I wanted people to see that for this thing, it's horizontal. It's not increasing or decreasing. So we don't just ignore that. We understand that that's part of the function. It's just not increasing or decreasing. And a lot of times on tests, it's like for which subset or for which piece of the piecewise function is it increasing? For which intervals is it decreasing? And you're just answering this one or this one or this one, right? So we just wanted to understand how they all work. So decreasing here, none. So people either wrote none, or they wrote never, or they got really lazy and they went blah. Not at all, whatever. I'm just looking to see that you understand that it is not decreasing at any point. All right, we're running to the end of the time on this video, so I'm going to go ahead and stop this one, and then I will start another one for evaluating.